All right, let's get into it. We're going to pull back the curtain on one of the biggest challenges in the entire tech world, which is how do you manage just an unbelievable amount of data without everything just grinding to a halt?
I mean, seriously, just stop and think about that for a second. Every single day, you've got billions, with a B, of photos being uploaded, millions of orders being placed, messages flying back and forth. How in the world does a database keep up with that constant, overwhelming flood of information? Well, it's not magic, it's just some really, really brilliant engineering.
And it turns out the biggest apps in the world rely on two powerful secret weapons. They're called Replication and Sharding. So let's start with the one that's all about keeping your data safe. Okay, first up is Replication. And I want you to think of this one as the ultimate safety net for your data. Its entire job, its reason for being, is to make sure nothing ever gets lost.
So what is it? Well, the concept is actually beautifully simple. Replication is literally just the process of making identical, exact copies of your entire database. So you don't have just one copy, you have a bunch of them, all stored on totally different physical servers.
You know, it's a lot like if you had a single priceless document, like the deed to your house. You wouldn't just leave it sitting on your desk, right? Of course not. You'd make copies, you'd store one at home, maybe one in a safe deposit box, one with a lawyer. That way, if a disaster happens, like a fire or a flood, you're covered. Your document is safe. Well, databases use this exact same idea.
So the big goal here is what we call high availability and fault tolerance, which, is just a fancy way of saying keeping the system online even when things go very, very wrong. If that main server crashes, poof, it's gone. One of the copies, one of the replicas, just seamlessly takes over. And you, the user, you never even notice anything happened. This is absolutely crucial for something like a banking app, where losing even a single transaction would be a complete catastrophe. Or for YouTube, which needs all its video metadata available instantly all across the globe.
Okay, so replication is our safety net. That's for safety. But what about speed? I mean, when your database grows to the size of a small planet, just making more copies of it isn't going to make it any faster. For that, we need our second hero, Sharding, the speed engine.
So, unlike replication, which copies data, Sharding splits it. It takes one gigantic, slow, clunky database and just breaks it apart into smaller, much more nimble little pieces. And we call those pieces shards. Each shard holds its own unique part of the total data.
The best way to get a feel for this is to just imagine a huge library. Imagine if every single book was stored in one single colossal room. Finding anything would be an absolute nightmare, right? So instead, what do libraries do? They organize. They put books into different rooms. Fiction over here, history over there, science in that room. Sharding does the exact same thing for data, and it makes finding what you're looking for incredibly fast.
The goal here is pure, unadulterated scalability and performance. And it works by using something called a shard key. For example, a system might decide that all users with IDs from 1 to 1 million, they go into shard 1. And then users from 1 million up to 2 million, well, they go into shard 2, and so on. Instagram does this to split users by region. So if you're in Japan, your data is probably stored on a server that's physically closer to you. And Amazon, of course, does this to manage its absolutely endless stream of customer orders. This is how you handle massive, massive growth.
So we have our safety net and our speed engine. Let's put them side by side, head to head, to really make the difference between them crystal clear. Okay, let's just break it down. With replication, the data is the same exact copy everywhere. The whole point is to survive a failure. But with sharding, each server holds a different little piece of the data because its goal is to handle massive scale. Replication is all about backup and high availability. Sharding is all about massive growth and speed. One is like making photocopies. The other is like splitting a giant puzzle into smaller sections. They're solving two fundamentally different problems.
Now, with that clear distinction, you might be thinking, okay, so I have to choose one or the other. Classic showdown, safety versus speed. But what if that's the completely wrong way to look at it?
This is the key question, right? It's the one every architect of a huge system has to ask themselves. Do you go for fault tolerance or do you go for performance? Which one do you pick?
And the answer is a big, fat no. You don't have to choose. In fact, the most powerful, the most resilient systems on the entire planet, the ones that basically run our digital lives, they don't choose. They combine these two techniques into one seriously powerful partnership.
And the way they combine is actually incredibly elegant. It works like this.
First, you use sharding to break your enormous database into all those smaller, faster pieces. Great, that solves your speed problem, but what if one of those individual shards fails? Well, that's where replication comes in. You then create backup copies of each individual shard. And boom, you get the best of both worlds, a system that is both lightning fast and incredibly resilient.
So, if there's one thing to take away from all this, it's this simple. Replication makes your data safer by creating backups. Sharding makes your application faster by splitting up the workload. One is your defense, the other is your offense.
And at the end of the day, it's this dynamic duo that lets modern apps handle a scale that we really couldn't have even imagined a few decades ago. As the saying goes, together, they help modern apps handle millions or even billions of users. It's that powerful.
So now you know the two secret weapons that power the biggest apps in the world. But knowing the what is really just the beginning. The truly hard part, the real challenge, is the how. Like, how do you actually choose a shard key to split your data without creating huge imbalances? What happens when you have to reshard everything? That's where the engineering gets really interesting.